Welcome to ClickMyProject.com. Now we are going to discuss about the project Automatic Voice Disorder Detection using Self-Supervised Representations. Now we are going to discuss about the abstract of the process. Speech disorder concerns the communication issues as well as the hearing, speech language and fluency also. A speech recognition system is proposed to distinguish between the normal person as well as the person having the speech disorder using the MFCC method, that is the Mel Frequency Cepstral Coefficient. The speech disability focus in this work is stuttering, which is carried out on normal speaker as well as the abnormal speakers. In this dataset we have both the dataset having the normal as well as the abnormal speakers, that is having the stuttering speakers also. This paper presents the capability of MFCC to extract the features from the signal could be used to recognize the speech disorder. Then the classification performance will be evaluated by means of the accuracy. Hence in this process we have considered the three major steps like the feature extraction, classification and performance estimation. So by these three steps only we have played a most important role in this project to identify whether the person is having the disorder or not. In case of a disorder, the message box will be pop up to display this is the disorder persons or else the normal persons. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists of the modules such as input signal, pre-processing, feature extraction, classification and finally performance estimation. At first the input signal is taken from the dataset. The dataset having the different kind of speech signals which is taken from the different persons, which consists both the thing of normal as well as the abnormal signal. The user can select any one signal from the dataset. After the selection of the signal from the dataset, the pre-processing will be carried out. In this pre-processing we have two stages will be there. One major stage is signal reshaping. For example, if I am giving the signal which is having the too much of the length, in the sense it will be shortlisted in the length to optimize the size of the signal. After doing the signal reshape, the feature extraction will be carried out. Before that, in the pre-processing itself, the filtering is applied to remove the noises from the signal. After doing the filtering, the feature extraction will be carried out. In this feature extraction, we have three kinds of features will be extracted from the signal, that is based on the mean, standard deviation and variance. After doing the feature extraction, the collected features will be taken based on the pixel peaks as well as the difference between the peaks. After the feature extraction, the classification will be carried out. In this classification step, the deep planning is used to classify the signal as normal or abnormal. We are going to use the deep planning such as the convolutional neural network, that is the CNN algorithm is used to classify. After estimating the normal and abnormality of the signal, we just doing the performance measure by means of the accuracy and the error rate. So for calculating the accuracy we need parameters like true positive, true negative, false positive and false negative. These based on these parameters we generated the formula to predict the accuracy as well as the error rate. Now we are going to discuss about the running procedure of the process. At first open the Spider 3.7. After doing that we have to change the directory like this, so where the file is present. After that we have to open the main file.py, then the code will be appears like this. So we have to run the click button. Then after clicking the run button, so we have to select the signal from the dataset. In this dataset we have both the normal as well as the abnormal signals will be there, so we have to select any one signal from the dataset. After doing the selections, the input signal is placed in the console in the title of input signal. Actually the size of the input signal is too much of length, so we have to shortlist as an 1000. So after shortlist this one, we just doing the filtering. So in this filtering you can see the difference here. The peaks will be altered in this input as well as the filtered signal. So after doing the filtering, the noises present in this signal will be removed during the filter. Here we are using the Butterworth filter to remove the noise from the signal. After doing the filtering, the feature extraction will be carried out. So in this feature extraction, the feature will be extracted based on the mean standard deviation variance like this. So after doing the feature extraction, that will be generated as a test feature. So after that we have to segregate the dataset data into two things, that is the test data and then the second one is the train data. So we have to split the test data and train data separately. After doing the splitting of test train separately, we just applying the convolutional neural network algorithm to classify whether the input signal is normal or abnormal. So here the convolutional neural network is applied. You can see the results here. So the final classification result will be displayed as abnormal. Basically we are selected the signal from the abnormal folder, so the results will be generated as an abnormal based on the classification. After doing the estimations everything, the performance analysis will be carried out. So in this performance analysis, the accuracy of the CNN will be evaluated in this process. That will be achieved around 99.2%. Then the overall error rate is achieved around 0.7 something.